Solving absolute value inequalities. When we talk about absolute value, what we mean is the distance from zero. Oftentimes, students think of absolute value as taking the opposite of a number, but absolute values are always going to be positive values because distance is always positive. For example A, let's describe all the values within a distance of 3 from the number 2. Let's start by drawing a picture of what we're talking about here. So here's the number 2 on the number line. 3, 4, 5. 5 would be 3 away from 2 going to the right. 1, 0, -1. And going down to -1 would be 3 units to the left, right? So we're talking about all the numbers that are in between -1 and 5, with 2 being in the middle. What we want to do is think about having this be in absolute value. So we want to say that any number -2, the distance between, so when I subtract those numbers, x and 2, we're saying the distance between those numbers is going to be less than or equal to 3. So this is how we would write the inequality. If I wanted to solve this inequality statement that I just wrote, I would rewrite this as two different things. X minus 2 is going to be less than or equal to 3, or x minus 2 is going to be greater than or equal to -3. What I do is I write the inequality exactly as I see it, removing the inequality signs. And then the second time that I write it, I switch the inequality sign to be the opposite, and I take the opposite of the number that was there. Let's solve both of these and see what answers we get. I'm going to add 2 everywhere to get the x by itself. And so I end up with x less than or equal to, oops, that should be a plus there, right? Less than or equal to 5. That matches with what we saw in the graph. And here I get x greater than or equal to -1. That also matches with what we saw in the graph. Let's look at example B. In example B, I want to find numbers that the distance between 2x plus 3 is less than 7. So I've got some value on the number line. And I want the distance to be between 7 and -7. I want the distance away from that to be between -7 and +7. So I'll write this as two separate inequalities. Let's move this over. We can write this as 2x plus 3 is going to be less than 7, or 2x plus 3 is greater than -7. That matches up. The first inequality is on the right, and the second inequality is on the left. All right, let's subtract 3 everywhere. So 2x is less than 4, or 2x is greater than -10. And then we'll divide by 2. So we get that x is less than 2, or x is greater than -5. So if we put those together, let's see, on the number line, we're taking all the numbers that are going to be greater than -5, but less than 2. So in interval notation, I could write my answer as -5 parentheses up to 2. All right. For example C, we've got an absolute value sign but it's being multiplied by -2. So we need to get rid of the -2 as our starting point before we change this into two different equations. So I'll start by dividing both sides by that -2. And when I do that, I need to remember to switch the inequality sign. So this is going to be the absolute value of k minus 4 greater than or equal to 3. Right, let's draw a picture to think about what's happening here. I have some number and I want its distance to be more than 3. So I'm wanting everything outside over here farther away than 3 and outside here farther away than -3. I want the distance to be more than 3. So looking at that picture, on the right-hand side, I'm going to have k minus 4 greater than or equal to 3. And then on the left-hand side, I'll have k minus 4 less than or equal to -3. All right, let's add 4 everywhere. And then we have k greater than or equal to 7, or k less than or equal to 1. So everything here, oops, or everything here. So I have to list this as two separate sets. I'll have everything going from -infinity up to 1, including 1 as the endpoint. And then I'll have everything, including 7, up to positive infinity. All right, one more example. This absolute value symbol has a 4 being added to it. So I want to move that away. I want to move the 4 away before I switch to two different inequalities. So I'm going to subtract 4 from both sides. All right, so now, oops, that should be 6. So I have some number and I want the distance to be more than 6 away from it. So I want everything over here and I want everything over here. So my two inequalities are going to be that x minus 2 is greater than or equal than 6, or x minus 2 is less than or equal than -6. Let's add 2 everywhere to get the x by itself. So I have x greater than or equal to 8, or x less than or equal to -4. So our answer is everything from here going to the left, and then everything from here going to the right. So again, we have to write this in two separate interval notations. I will have -infinity up to -4, and then also 8 up to positive infinity.